Hello everyone, my name is Yunglong Chen. In this video, I will show how my task A work in Minecraft use the Maker build. I use Make to compare my project. The Maker automatically compares all C++ files and link the MCPP library. As you can see, I'm a make. Also, you can see the building the with the node 0. Its first function is funding pod. The first function is find the plots. It connects to Minecraft, get the player position and searches for flat dry land around the player, while the plots are printed on the console. You can see in the map. Here is a player location, position, and its size is 115. And right now we need waiting in funding plots. And right now you can see from the 3 ready plots. And right now is a transform plots. The program clean train remove level and row and rebuild a clean glass platform for the village. After the ground is ready, place or building build a cardboard stone wall around the village. It keeps the same height on each side and the decorative slabs on top. And here you can see the waypoint. Finally, compute what the waypoint creates navigation points inside the village. There will be used later in task C for path generation. All functions in task A work successfully. Police are found the terrain is flatter ending. Walls are built and waypoint are generate. Thank you for watching.
Hi everyone, my name is Yi Wang and I'm responsible for Task B, House Building and Interior Generation. The goal of this task was to give life to empty plots from Task A by building houses that look realistic, have clean structure, and feel livable inside. First, I focused on the exterior. Each house is built automatically with strong cold wall and a simple yet elegant roof. The house gradually increases in height, which makes the village look more natural and also helps test whether the structure works correctly at the different levels. Every floor has enough vertical space so interior feels open and comfortable. Inside each house, I designed a recursive algorithm to divide the space into rooms. The program checks the proportions of the floor and splits along a longer side, keeping both sections balanced. It continued dividing until the room reached a proper size, and it's limiting very large rooms, so the layout stays realistic. This makes the interior well organized rather than random. For the doors, the system automatically places them near the middle of each wall, with a small random offset so they are never blocked or overlap. That means every entrance looks slightly different but still easy to walk through. Then comes the furniture. Each room receives a rotating theme, a bedroom, a kitchen, a living room, or a bathroom, so that every time appears evenly. Furniture position shift slightly to avoid blocking doors. Give each room a bit of variety while keeping it believable and functional. Behind all these features, I organized the code with clear data structures. Each house stores its size and position. Every room keeps track of boundaries and doors, and all construction logic is handled by one main builder component. This makes the design modular, easy to test, and simple to expand later. I also use a semi-random system so the program can behave differently in normal runs but stay consistent for testing. That balance keeps the result both varied and reliable. Finally, through the implementation, I followed three main programming principles. Defensive programming to prevent crashes from bad inputs. Structured programs so each function does one clear job, and contract-based design so each part knows exactly what to expect from the others. Overall, Task B builds a system that is stable, creative, and repeatable. By combining recursive algorithms, control randomness, and display structure, I turn abstract logic into a living, believable village.
Hello, my name is Andrew Matthew Swasti from the group Creeper Guild, and I'm assigned with Task C. So at first, my Task C composed with 9 different files. Two of them, one of task C.cpp is basically the main file. This is the test file that is essentially just reading the inputs. Connect points, this takes the waypoint vector and the plot vector to find the closest of both of them. So we find two waypoint that is closest to each other and a plot entrance that is closest to a waypoint, and we store them in this path structure that is essentially only having start and end. Then pathfinding, this is basically just the pathfinding algorithm that I use. I decide to use Dijkstra to find the optimal path between those points, the paths that the start and end, and building path, which basically handles all the placing blocks in the Minecraft. So since in task C we can't use any STL containers, so I decided to create my own basic containers. First is explored, which is basically a dynamic class array, which as we can see here, it has the size, it has counts, and it has the array. And the features that I implement is first is finding. It takes in a coordinates and return us the node that if it's found. If it's not found, it will just return a null pointer and an insert. And this creates a dynamic array because every time if the size is not enough, it will grow and it will increase the size of the array dynamically. Then second, I have to explore queue. This is basically a priority queue for the Dijkstra algorithm. I implemented first is to check if it's empty or not, pushing to the queue, getting the minimum, so basically getting the least depth, the least weight on it, popping it, so removing the node and returning the node, then removing the node without removing a certain node that returns a bool if it returns true if it's removed, and false if there's no node that has the same value of this. And this is basic, and a node is basically representing one block, basically a vertices for the Dijkstra algorithm, and paths as I showed you just now basically only have start and end. So this is one of my tests for my code. It consists of a lake and surrounded by a mountain. So I intentionally place waypoint on the mountain and one in the middle of the lake. This shows that my code will traverse over the water as short as possible and then finding the flattest path even if there's no fully flat path. It will try to find a height difference of 1 if possible. So as you can see, rather than my path gonna go here, traversing over a lot of water, to be closer to that, it will first get out of the water quickly, like this 5 block, and then after this, it will try to find a path that can get over the mountain and reach to that waypoint without traversing more than 1 height difference. So first you can see after the path reach here, the shortest way possible to reach over that mountain is probably here, going up this, but then there's a 2-block jump, then going over there. So because there's a 2-block jump, my code will purposely try to avoid it if possible if it finds a path that doesn't consist of another 2-block jump, which we can see there is here. After going here, there's 1-block jumps over here to get over the mountain and then reaching that. Even though it might be a little bit longer, it doesn't traverse over a 2-block jump. And then it will connect to the entrance and then try to connect to that other one. So let's run the code. First we make the test. And then we run it. So going back to our Minecraft, you can see that the code is actually running. It traverses over the 1 block jump rather than going over the 2 block jump, reaching that waypoint, and then connecting that waypoint to here, to the entrance. So as you can see, my code succeeds to find the flattest path and the shortest path without getting over much water, without traversing over 2 block jumps, and etc. So I also really like this test for my code, where as you can see, this is a waypoint and this is a plot entrance. And it's obvious that there's a short path here that it can just go over here and get to the plot entrance, but it needs to traverse over a lot of height difference and it's not really flat. Even though it's clearly, you can clearly see there's an actual flat path to get over the plot entrance. And in theory, my code should prefer that flat path to go to the plot entrance. And I also noticed that there's this little bit of a hill that if you break these 3 blocks, 1, 2, 3, to get over this waypoint, the code need to place a block like somewhere here or like other place where it can reach this waypoint. So it basically just need to place a block to reach this waypoint. So let's see if my code works. So I've run my code, and as you can see, it placed the block there to reach that waypoint, and then it traverses over a flat path to get over this plot entrance, and it builds the waypoint. So that is all for task C.